Okay, these were the dilation notes. So dilations are either expansions or contractions. We're either making the figure larger or smaller. It's going to stay the same shape, but it's getting larger or smaller. Okay. So our description of a dilation includes the scale factor and the center of dilation. The scale factor is what we're multiplying it by to see if it gets to see the new size. So if we're multiplying by a number that's greater than 1, it's going to get larger. If we're multiplying by a number between 0 and 1, it's going to get smaller. It's going to contract. Okay, so the scale factor is how much larger, how much smaller it's getting, how much is it expanding by, how much is it contracting by. The center of dilation is the center point from which it expands outward from. So for our purposes, it's almost always going to be the origin. It might not be. There's like one problem on the practice. It's not. But for everything else, it is the origin. Okay. So how we're going to write this is D is going to represent a transformation. It can be any transformation. Well, it's going to be a dilation transformation, but it's a dilation. Okay. We're going to put 2 subscripts. The first is going to be the center of dilation. Center of dilation, which is almost always going to be 0, 0. And then we're going to put in the scale factor as our second subscript. Scale factor. Okay. So if you look at our example over here, that's the center of dilation, and that's our scale factor. The reason it's just a 0 is since the origin is 0, 0, we can really just write 0. Center of dilation is 0, the origin, and then our scale factor is K. In the first example, it's going to be 2. Okay, so again, twice as big, expanding out from the point 0, 0. Right? And then if the scale factor K, we already mentioned this, is greater than 1, then the dilation is called an expansion. If it's between 0 and 1, it's going to be a contraction. Right? If you multiply a number by another number that's greater than 1, that number gets larger. If you multiply a number by a number that's between 0 and 1, that number gets smaller. So to dilate, we're going to multiply by the absolute value of the scale factor. We're not going to really have any negative scale factors, so you don't really need to worry about absolute values too much. All we're going to do is multiply by the scale factor. Okay, and then properties that are preserved under a dilation are angle measures, parallel lines, collinear points, midpoints, and its orientation. The reason these are preserved is because under a dilation, say we have a triangle, we dilate it, we expand it by maybe a factor of 2 or 3 or something. It's going to have the same shape. They're just going to be different sizes. So they're going to be like similar figures where you have the same shape, different sizes. So if you have the same shape, you're going to have the same angle measures. If you have a parallelogram and you dilate it, it's still going to be a parallelogram. It's still going to be the same shape, so the parallel lines are still going to be parallel. If you have 2 points here on this line and you dilate it, those points are going to expand outward, and they're going to still be on the same line, so they're still going to be collinear. Collinear meant 2 points on the same line. So if you have 2 points on the same line, they expand outwards, they're still going to be on the same line. Midpoints, if this had a midpoint, we expand outward, still going to have the same midpoint there. Okay, the midpoint will expand out to still be the midpoint, the endpoints will expand out to be the endpoints. Okay, and the orientation is going to be in the same direction, the same, it's going to be oriented in the same direction, facing the same way. All right, so let's do the 2 examples. Example 1, find the image of triangle ABC under the dilation 0, 2. So again, our 0 represents, the first subscript represents the center of dilation. The second subscript represents the scale factor. So we're expanding outward from the point 0, 0. Okay, all we do is take our scale factor of 2 and we multiply each of the coordinates. So Negative 1 times 2 is negative 2. 2 times 0 is 0. So first let me graph the original. We had negative 1, 0. We have 2, 2. We have 3, negative 2. And we're going to do a dilation. This is a expansion because the scale factor is greater than 1. Okay, so since the scale factor is 2, it's greater than 1, and so it's an expansion. It's getting larger. So we multiply negative 1 and 0 by 2, and we get negative 2, 0. It's now twice as far from the origin as it was before. Okay, 2, 2, we multiply by a scale factor of 2. That's going to be 4, 4. Okay. This point is now twice as far from the origin as it was before. The original was 2 right, up 2. Now we're 4 right, up 4. Okay. Multiply by 2, we get 6 and negative 4. The original point was 3 over 3 down 2. Now we're over 6 down 4. So our point is twice as far away from the origin as it was before. Okay, all the points have gotten twice as far from the origin as they were before. Second example, our scale factor is 1/2. So this is going to be a contraction because our scale factor is between 0 and 1. So we're still multiplying, it's just that this is going to be a contraction, meaning it's going to get smaller. Okay, so our original here, in blue, we have negative 2, 0. We have 2, 4, and we have 4, negative 4. Okay, so here's our original triangle. It's going to get smaller, it should contract. Negative 2 times our scale factor 1/2 gives us negative 1. 0 times 1/2 gives us 0. So we got half as close, twice as close, half as far to the origin. Okay, it was at 2, now it's at 1. It's half the way there. Okay, 2, 4. 2 times half is 1. 4 times half is 2. So now instead of being over 2 and up 4, we're over 1 and up 2. So we're twice as close. We're half as close. Half as far, twice as close. Maybe. I don't know. 4 times half is 2. Negative 4 times half is negative 2. We were... Oh, I only went 3 down. That wasn't my problem. Sorry, guys. This was for negative 4. Did I go up all the way here? I think I didn't draw it very well. So, there we go. And then 2, 2. Okay. So, again, this was 4 over 4, down 4 from the origin. Now it's over 2, down 2 from the origin. So it's half as far, twice as close. Okay, and that's it. You just multiply by the scale factor. Draw it. Dilations. Not even 9 minutes.